Hi, everyone. So today we are going to learn about the binomial theorem. And so our goals today are to explore Pascal's triangle, learn how to expand binomials, and to find any term in a binomial expansion. So we're going to talk about Blaise Pascal first. He was a mathematician and a philosopher. He came up with the mechanical calculator, which was built in 1642, created about 50 prototypes. He's most famous for, I'd like to say, Pascal's triangle. Pascal's triangle looks something like this, where it starts with 1, 1, 1, 1, 2, 1. See if you can figure out what I'm doing here, what the pattern is. 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, and 1. Did anybody figure that out? So if you didn't, what I did was alongside you see these ones, but what I was doing was I'm adding these two terms here. So 1 plus 1 is 2. 1 plus 2 is 3. So this is something, so like 3 and 1 is 4. 4 plus 6 is 10. 1 plus 4 is 5. 5 plus 10 is 15, etc. So this goes on, and Pascal's triangle is infinite. It just keeps going on and on and on. And notice, though, that row 0 is here. Then we have row 1. Then we have row 2. So this is row 2 technically, but it is the third one down. Row 3 has 3's in it. Row 2 has 2's in it. Row 4 has 4's in it, etc. There's a lot of patterns you can find with Pascal's triangle. Here's a few of them. Patterns with one triangle. So we have our ones, we have our counting numbers, and then we have our triangular numbers right here. Pascal's triangle is symmetrical. It does have, another thing is that it has horizontal sums that look like this: 1, 2, 4, 8, 16, 32. If you notice about these, that this is 2 to the 0, to the 1, 2 squared, 2 to the third, to the fourth, etc. In addition to that, you have powers of 11. This is kind of neat. 1, 1, 1, 121. So that's 11 squared, 11 cubed. So Pascal's triangle has so many different really cool things about it. In addition, it also contains part of the Fibonacci sequence, which is 1, 1, 2, 3, 5, 8. If you notice that it's 1 plus 1 is 2, 2 and 3 is 5, 5 and 3 is 8, and these numbers are all found in here. But what we're going to do with Pascal's triangle is we're going to use it to expand the following binomials. And so what I love about Pascal's triangle is that it just has so many patterns in it. Anything to the 0 power is 1. So here we are at 1. A plus B. So if I said A plus B like this is to the 1 power here, and this is to the 1 power here also. But notice the coefficients are also 1. A plus B to the 2nd power, that's actually A plus B times A plus B. If I multiplied these out and FOILed, I would get A squared plus AB, which is plus 2AB. B times B is plus B squared. And again, I want you to notice my coefficients. Here's 1. Here's 1 and 1. Here's 1. Here's 2. Here's 1. And if I multiplied this out, which is actually A plus B times A plus B times A plus B, what I'm going to get is this right here, a plus b times a squared plus 2ab plus b squared, and I need to multiply that out. And so foiling that, I'm going to get, or multiplying each term out, I'm going to get a to the third power plus 2a squared b plus a b squared plus, this is b times a squared, so a squared b plus this times this, which would be 2ab squared plus b to the third power. And adding like terms, I'm going to get a cubed plus, now I've got an a squared b here, and I've got an a squared b here. So that's going to be 3a squared b plus, so those are gone, ab squared plus 2ab squared makes 3ab squared plus b cubed. And if you notice, my coefficients, they are 1, 3, 3, 1. And if you recall from Pascal's triangle, 1, 1, 1, like that, 1, 2, 1, 1, 3, 3, 1. And so there's a couple of things to notice here. The next row would be 1, 4, 6, 4, 1. And if you notice that this 1, 3, 3, 1, look at the letters. You've got a to the third power, then you have a to the second power, you have a to the 1 power, then you have no a to the 0 power technically. And then here you have no b, so it'd b to the 0 power pretty much, b to the 1, b to the second, b to the third. So if you were to predict what would happen with a plus b to the 4th power, it might start something like this, a to the 4th and b to the 0 plus a to the 3rd, b to the 1 plus a to the 2nd, b to the 2nd. And then what you would do is you would take your values right here, which are our coefficients, and you would plug those in, 1, 4, 6, etc. A couple of other things too while we're on this page is let's look at the sums. So let's see if this is the sum of the exponents. So if this is an x to the 3rd power right here, notice that this is a 3, 2 plus 1 is also a 3, 2 plus 1 is a 3, 3 is a 3. What about to the 4th power? You've got 4 plus 0, 4, 3 plus 1, 4, 2 plus 2, 4, and so on. So we're going to get more into that. That's kind of interesting. 1, 1, 1, 1. You've got 1, 2, 1, 1, 3, 3, 1, and 1, 4, 6, 4, 1. So for the 5th power, what do you think? We're going to try to go 1. So let's see here. So if it's x to the 4th, we start off with x to the 4th. If it's x to the 5th, we're going to start with x to the 5th and then no y. So we're going to call that a 0. Plus, then the next term is going to be x to the 4th, 1y. Then the next term is going to be x to the 3rd and 2 y's. And the next term is going to be x to the 2nd and 1y. The next term will be x to the 3, 2, 1, and y to the 0, 1, 2, 0, 1, 2, 3, 4. And then the next term would have no x, but a y to the 5th. So if you notice, each one of these has to add up to 5. So if we have 1, 4, 6, 4, 1, my coefficients for the next row are going to be 1. The next term will be 1 plus 4, which is 5. 4 plus 6, which is 10. 6 plus 4, which is 10 again. 4 plus 1 which will be 5, and 1 on the end, which is 1. So rewriting this, you're actually going to get x to the 5, anything to the 0 power is 1. So we have x to the 5th plus 5x to the 4th, y, 4, plus 10x cubed y squared plus 10x squared y cubed plus 5x y to the 4th plus y to the 5th power. And that is your x plus y to the 5th power expanded. So a few things here. It's just what we did right here. Just notice that, let's see, 1, 1, 1, 2, 1, 1, 3, 3, 1. And this is only if you have a plus b. But if I were to put numbers in front of here, that would change my coefficients, just so you know. In addition to that, we know that if it's, let's say, a cube here, these all add up to 3. So 2 plus 1, 2 plus 1 is 3. Again, if it's a 5th power, that's 5. That adds up to 5. That adds up to 5. That adds up to 5. So something else is that if I were to count the terms, so like if I have 1, 2, 3, the third term, so if I'm looking at the third term, then the coefficient right here, the end coefficient, which is a 2, is 1 less. So the coefficient is would be 3 minus 1, so that would be a second power. Likewise, if let's say I'm on the third power, then I'm going to say, well, 1, 2 would be 1 less. Or if I'm the fourth power one, if I said 1, 2, 3, fourth, the fourth term in, the fourth term in would be, again, 4 minus 1 power with this 3. And let's see, fourth power gives me 1, 2, 3, 4, 5 terms. A third power gives me 4 terms, etc. So there's one more term than the degree. So that's what we're saying. If you have a plus b to the second power, you have 3 terms. A plus b to the third power has 4 terms. We were just talking about that. In each term, the sum of the exponents is the power to which the binomial is raised. So this is a 4. This is a cubed 1, so that's 4. These are equal 4, and these equal 4, and that's equal to 4. And lastly, the exponents of the first term, a, start with the degree of 0 and decrease. So if you have to the 5th power, remember that x would be to the 5th power, but y would be 0. And the next term would be x to the 4th power, y to the 1. So the 5s are decreasing, and the y's, or the ab's, are going to be increasing. So the next term would be x to the 3rd, and then that would be y to the 2nd. So 0, 1, 2, 5, 4, 3, and of course, don't forget your values here, 1, 5, 10. Okay. Just another triangle, Pascal's triangle, just showing you the different coefficients again. Keep in mind that it always starts with 1 on top, and all the way down are 1s on both sides. And so for this value right here, which has 2 terms, remember, if it has 2 terms, means that it's going to be a plus b to the 1 power. So a couple of things to ponder in the expansions. How does the number of terms relate? So again, if I have this to the 3rd power, I'm going to have 4 terms. The sum of the exponents, these, if I have, this says x cubed y to the 5th power, then this is a plus b to the 8th. What happens to the degrees as you move from left to right? Well, the a power, the first term, is going to decrease, and then the second term is going to increase. Okay. What's always true about the first and last terms of the expansion, the first term is always going to be x to the 5th, the last term will be y to the 5th, and the coefficients are always going to be 1 as long as there's no values in front of the x plus y. Meaning, if I have if I have x plus y like this by itself, that's what that's going to look like, the first and last term. However, if I were to put something in front like that, okay, that's going to change everything. So that's not going to give you this right here as easy as that. So this is the actual formula for the binomial theorem. It's actually a series, which is a sum. And as you can see, we're adding terms. What you can see here is that there's your n, which is for your n term right here. And then the first term starts off at 0. And then these drop down n minus 1, n minus 2, etc. And these increase 0, 1, 2. So let's try expanding a term or a binomial. So we have x plus 2 to the third power. So we don't want to do this. We don't want to add or multiply x plus 2 times x plus 2 times x plus 2. We don't want to do that. What we want to do is we want to learn how to write this binomial as an expansion. So what we're going to do again is we're going to take the first term, which is x to the third power. So we always start off x to the third power. Y, or our 2 value, is going to be 2 to the 0 power. The next term is going to be x to the second power, because remember, it starts off with 3. The next term is going to be 2. The 2 will then be to the 1 power, okay? The next term will be x 3 to the 1 power, and 2 will be to the second power. X to the 0 times 2 to the 0, 1, 2, 3 power. And then I'm done with that. However, I still need to put in my coefficients, and this being a cube, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So this right here is the row I'm looking at, which is going to be my coefficients, 1, 3, 3, 1. So I rewrite it one final time. Anything to the 0 power is 1. I have x cubed plus, now numbers multiply with numbers, so we have 2 times 3 is 6, so 6x squared, plus, that's a 4, 4 times 3 is 12x, plus, that's a 1 times 8. So this is my expansion, so box that up. That's not too bad. So let's try this again. So this is to the 4th power this time. So when we multiply these out, we're going to start with x to the 4th power times, I'm going to use parentheses, 2y to the 0 power, plus x to the 3rd power times 2y to the 1st power, plus x to the 2nd times 2y to the 2nd power, plus x to the 3rd times 2y to the 3rd. Remember, these all have to add up to be 0. So let's see here. 4 plus 0, 3 plus 1, 2 times 2. And so this should be 3, 2, 1. So let's fix that real quick. That's gone. And so this is to the 1. So 4, 3, 2, 1, 0, 1, 2, 3. And then the last term is going to be x to the 0 times 2y to the 4th power. Now don't forget to put in your coefficients, which is for the 4th power is 1, 4, 6, 4, and 1. So when you multiply these out, anything to the 0 power is 0. So what we have is just x to the 4th for the first term. For the second term, we have 4 times 2, which is 8. So we have 8x cubed y plus, now this one is 2 squared, so that's actually 4y squared. So 6 times 4 is going to give you 24x squared y squared plus, and then this one, 2 to the 3rd power, is 8y cubed. So that's 4 times 8, which is 32x y cubed. And then the last term, x to the 0 power, is 1. But 2 to the 4th power is 16, and then you have y to the 4th. So the last term is 16y to the 4th. So you're going to box all that up. That's the entire expansion for this problem. Okay, lastly, you have the x plus 1 to the 5th power. I'd like you to try this yourself. So if you're watching the video, pause it, try to do this yourself, and then start it again. So how did you do? So we're going to go x to the 5th, and then we have 1 to the 0. And you notice that these aren't always letters, of course. You can have numbers instead of A, B, or Y, or whatever. So the next term is going to be x to the 4th, and then we have 1 to the 1st, plus x to the 3rd times 1, 0, 1, 2, plus x to the 2nd times 1, 0, 1, 2, 3, plus x to the 1st times 1 to the 4th, plus x to the 0 power times 1 to the 5th. And don't forget, the 5th power, you're going to have to put in the coefficients. So don't forget, to the 5th power, if you need to rewrite it, that's fine. 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And then this one, of course, is 1, 5, 10, 10, 5, 1. So when it's all said and done, my expansion is going to, this binomial theorem, binomial meaning 2, is going to be x to the 5th plus 5x to the 4th plus 10x cubed plus 10x squared plus 5x plus 1. And if you want to check your solutions too, keep in mind, if it starts with the 5th power, it's the 5th power, you've got 5, 4, 3, 2, 1, 0. 0, 1, 2, 3, 4, 5. Expanding a binomial difference is a little bit different, but when it's all said and done, it's pretty simple. You're just alternating plus and minus. So for this one, you start off and go x to the 6th, y, negative y to the 0, plus x to the 5th, negative y to the 1, plus x to the 4th times negative y to the 2nd, plus x to the 3rd times negative y to the 3rd, plus x to the, let's see here, 6, 5, 4, 3, 2, negative y to the 0, 1, 2, 3, 4, plus x to the 1, negative y to the 5th, plus x to the 0, negative y to the 6th. And again, we need to plug in our coefficients, which are 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, add them up, 6, 15, 20, add them up, 15 for those two, add these two up, 6, 1. So my coefficients, let's see, oh my God, I was able to expand that. So my coefficients, once I plug those in, are going to be 1, 6, 15, 20, 15, 6, and 1. So when I write my expansion for x minus y to the 6th power, I'm going to get, this is anything to the 0 power is 1. So I'm going to get x to the 6th. Now, a negative times the positive, of course, is minus. So you're going to have minus 6x to the 5th y plus, because that's negative times negative, which is squared, 15 x to the 4th minus, that's cubed, so it's negative, 20 x to the 3rd, oh, I forgot my y, hold on, y squared, plus 20 minus 20 x cubed y to the 5th plus where am I at? 15 x squared y to the fourth, because negatives to the fourth power is even, minus 6x y to the fifth plus y to the sixth. There we go. And so that is the expansion of the binomial theorem for x minus y. But if you look at it, positive, negative, positive, negative, positive, negative, positive. So it's always alternating. So binomial theorem tricks and secrets. It is symmetric. The total terms in any expression is always plus 1. And the sum of the exponents. So if this was 6, if my exponents if it's to the x power, then all of these are going to be sums. So that would be x squared y to the fourth, or that would be x cubed y cubed. These have to add up to be that term right there, the exponent. So right now what you have is to turn off the computer and walk around and do your exit ticket, which is the Star Wars extravaganza. So the four problems. So what I need you to do is to go pick up the worksheet and walk around the room. You may work together and complete the exit ticket. Thank you.